The Explorer missions, which began more than 40 years ago, stand as one of the most significant and enduring achievements in the history of space exploration. Launched by NASA in 1977, the twin spacecraft Explorer 1 and Explorer 2 were originally tasked with investigating the outer planets of our solar system. However, their mission has far exceeded these initial objectives, continuing to send invaluable data from the very edge of interstellar space. The story of the Explorer mission spans over 35 years and 13 billion miles. It all began in July 1972, when NASA initiated a project that would eventually lead to the launch of two spacecraft in 1977. These spacecraft were designed to explore the outer planets, Jupiter, Saturn, Uranus, and Neptune. For nearly 5 decades, the remarkable Explorer spacecraft have studied our solar system and beyond, transmitting crucial data back to Earth. Yet, the latest transmission from these probes has been the most astonishing in over 20 years. NASA recently revealed that the explorers encountered an unknown force within the vast expanse of space, the nature of which remains a mystery. What exactly did the explorers find, and what prevented them from transmitting this discovery immediately? Before diving into NASA's latest revelations on this event, let's take a closer look at these extraordinary spacecraft that have been tirelessly observing the universe on behalf of our planet. These two remarkable spacecraft owe their launch to a rare cosmic alignment that occurs roughly once every 176 years. During this particular alignment, the 4 largest planets in our solar system, Jupiter, Saturn, Uranus, and Neptune, acted as guiding stars. Their immense gravitational pull created a slingshot effect, accelerating the spacecraft as they passed each giant planet. It was as if the spacecraft were being pulled along by an invisible cosmic rope, propelling them forward with a burst of momentum. This alignment, however, was a one-time opportunity, making it a fleeting chance for interplanetary exploration. To capitalize on this rare alignment, NASA launched 2 identical spacecraft in the 1970s, sending them on an epic journey of discovery. Explorer 2 embarked on its mission from Cape Canaveral, Florida, on August 20, 1977, propelled by the Titan IIIe launch vehicle. Explorer 1 followed soon after, leaving on September 5, 1977, for a twin voyage into the cosmos. Their primary mission was to study the gas giants Jupiter and Saturn, as well as the moons orbiting them. However, these brave explorers far surpassed their original objectives, venturing beyond the solar system's boundaries to the farthest reaches of our cosmic neighborhood. Explorer 1 and Explorer 2 have achieved many milestones on their incredible journey. They have outlasted every other spacecraft in history, venturing farther from Earth than any other human-made objects. In fact, they have crossed into interstellar space, becoming the first human-made probes to do so. Their journey beyond the influence of the Sun and into the unknown vastness of the universe has provided invaluable data, leaving scientists in awe. Now, after traveling over 12 billion miles from Earth, the spacecraft continue to surprise physicists with their discoveries. One of the most remarkable aspects of the Explorer probes is their use of self-powered radioisotope thermoelectric generators, RTGs, also known as atomic batteries. These RTGs convert heat from decaying plutonium into electrical power using the thermoelectric effect. What makes these generators so exceptional is their ability to function without moving parts, minimizing the risk of wear and tear and making them highly suitable for the harsh, distant conditions of space. Unlike solar panels, these RTGs do not rely on sunlight, making them ideal for deep space missions. However, as time passes, the decaying plutonium within the RTGs gradually reduces their power output. Despite this, NASA engineers have ensured the continued success of the mission by deactivating non-essential systems, which allows the spacecraft to maintain their core functions. The Explorer spacecraft were originally designed to use an 8-track tape system for data storage and playback. On-board scientific instruments collect various types of data, such as images, sound recordings, and measurements, which are then converted into digital format. This data is serialized and stored on the 8-track tapes, each of which contains 8 parallel tracks for efficient storage. When it's time to transmit the data back to Earth, the onboard computer reads the information from the appropriate tracks and sends it via the spacecraft's communication system, using a high-gain antenna to beam the data back to Earth. The tapes are made from special materials designed to withstand the harsh conditions of space, including radiation, extreme temperatures, and the vacuum of space. They also feature a metallic base layer, often made of stainless steel, that resists damage from micrometeoroid impacts. Despite their old-fashioned design, these tapes continue to function effectively, transmitting data to Earth every day. The accomplishments of the Explorer spacecraft have been nothing short of extraordinary. Their early observations of Jupiter and Saturn's moons, made over 40 years ago, astounded scientists and provided groundbreaking insights into the outer solar system. These two spacecraft have set the bar for long-term space exploration, providing us with a wealth of knowledge about our solar system and beyond, and continuing to push the boundaries of human understanding. The exploration of distant universes has shattered previous assumptions about moons once believed to be as dormant and heavily cratered as our own moon. Turns out these celestial bodies are actively involved in geological processes. Voyager 2, in particular, achieved several significant milestones during its mission, and as the spacecraft continue their remarkable journey, NASA has implemented measures to extend their operational lifespans over the past 3 years. Non-essential components and heaters have been powered down to conserve energy, allowing them to continue their missions well into the next decade, with an expected end date of 2030. For the scientists and engineers who have been part of this extraordinary mission since its inception, the culmination of the Voyager missions is a bittersweet moment. Their dedication and hard work have taken the project far beyond its original expectations. The data returned by the spacecraft has provided invaluable insights, led to countless scientific discoveries, and inspired generations of researchers and space enthusiasts. Voyager 1 and 2 were not just ordinary spacecraft. They were meticulously designed to be stable platforms with a rotation rate more than 40 times slower than the hour hand of a clock. This design minimized visual blur as the spacecraft captured images and data while traveling through space. Their exceptional imaging capabilities began to astonish both scientists and the public even before they reached the outer planets. The spacecraft started sending back pictures of Jupiter while still far from the planet, revealing the gas giant's swirling clouds and its iconic Great Red Spot, captivating audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly set the stage for the Voyager's groundbreaking observations. Slightly larger than Earth's moon, Io was revealed to be the most volcanically active body in the solar system. The spacecraft's instruments detected powerful volcanic emissions from Io, which were confirmed by the stunning images they captured. The volcanic eruptions of Pele, one of Io's most prominent volcanoes, reached heights more than 100 times greater than Mount Everest and covered an area nearly the size of France. In total, the Voyager spacecraft captured over 33,000 images of Jupiter and its moons, showcasing the planet's beauty and the incredible diversity of its moon system. Before the Voyager spacecraft received new warning signals, their discoveries had been nothing short of spectacular. One of the most astonishing was the detection of Jupiter's faint rings. This discovery added another layer of intrigue to the already fascinating gas giant. Voyager 2 also revealed that Europa, one of Jupiter's 53 named moons, had an icy shell believed to be more than 60 miles thick. These findings challenged previous assumptions about these distant bodies and fueled further investigations into the potential habitability of Jupiter's moons. After leaving Jupiter, the spacecraft received a gravity assist, which provided them with a final boost, enabling them to continue their journey toward Saturn. Without this vital gravitational slingshot, they would have been unable to escape the Sun's gravitational pull and venture further into space. Voyager 1 headed toward Saturn, passing by Titan, Saturn's moon, which is enveloped in an orange hazy atmosphere. The mysteries of Titan sparked much interest among researchers, leading to numerous observations and discoveries. Voyager 2, on the other hand, continued its journey, passing Saturn in 1981 and heading toward the more distant Uranus and Neptune. In 1986, Voyager 2 became the first spacecraft to visit Uranus, discovering 10 new moons, 2 new rings, and a magnetic field that was both offset from the planet's center and tilted relative to its rotational axis. The spacecraft also noted the planet's distinctive blue-green color, which is caused by methane in its atmosphere absorbing red light. Voyager 2's encounter with Neptune in 1989 revealed a unique world with the fastest winds in the solar system, reaching speeds of up to 2,100 kilometers per hour. The spacecraft discovered 6 new moons and observed the Great Dark Spot, a storm similar to Jupiter's Great Red Spot, which has since disappeared. Voyager 2 also provided the first images of Neptune's largest moon, Triton, which showed geysers of nitrogen gas erupting from its surface. After completing their primary missions, both Voyager spacecraft continued their journeys toward the edge of the solar system. Voyager 1 entered interstellar space on August 25, 2012, followed by Voyager 2 on November 5, 2018. These milestones marked humanity's first steps into the space between the stars, providing invaluable data about this previously unexplored region. The Voyagers have been measuring the density and temperature of plasma, ionized gas, and detecting cosmic rays and interstellar particles. The information collected by the spacecraft has helped scientists better understand the boundary between the solar wind, a stream of charged particles emanating from the Sun, and the interstellar medium. One particularly intriguing aspect of the Voyager missions is the inclusion of the Golden Record, a 12-inch gold-plated copper disc containing sounds and images selected to represent the diversity of life and culture on Earth. This time capsule was designed to convey the story of our world to any extraterrestrial civilizations that might encounter the spacecraft. The Golden Record includes greetings in 55 languages, a variety of music from different cultures and eras, natural sounds like thunder and bird songs, and 115 images depicting scientific information, human anatomy, and everyday life on Earth. The inclusion of this record reflects the hopeful and forward-looking spirit of the Voyager missions, symbolizing humanity's desire to connect with the universe. Although the Voyager spacecraft are now more than 12 billion miles from Earth, they continue to send data back to NASA's Deep Space Network. Their power supply is dwindling, but engineers have carefully managed the spacecraft's energy resources to extend their operational life as long as possible. It is expected that the Voyagers will continue communicating with Earth until at least 2025, after which their power levels will be insufficient to support their instruments and communication systems. The Voyager missions have inspired generations of scientists, engineers, and space enthusiasts. They represent humanity's curiosity and determination to explore the unknown, pushing the boundaries of what is possible. The images and data returned by the spacecraft have not only advanced our scientific understanding but also captured the imagination of people worldwide. The iconic pale blue dot image taken by Voyager 1, which shows Earth as a tiny speck in the vastness of space, has become a symbol of our planet's fragility and the need for global cooperation to protect and preserve it.